All right. I'm sure you all are getting tired. And so I'll try to keep this as brief as possible. I wasn't even going to be on this until about a week and a half ago. So I'm seeing this for the second time. So you guys are getting about the same kind of view as I am right now. I'm going to be talking about quality by design. And how many of you have designed programs? Okay, we've got a few hands. All right. Design is an interesting thing. So let's get into this. The agenda here is we're going to talk just 1 second about quality, 1 second about design, and then how does DDD help in a roundabout way. All right, so quality. We all kind of agree on this idea of quality. It's a very subjective thing. What one of us believes is a quality coffee pot or coffee maker may be different than what somebody else thinks is a quality coffee maker, but we all kind of have an idea that we want it to work to the level that we want it to with some level of excellence if we want quality. Design. It's even more nebulous. But I want to focus on this one. When it comes to design, the arrangement of elements or details in a product or a work of art. I think this is a pretty good definition out of Webster for what we mean by design in software. Design in software. All software does what it is designed to do. All software does what it's designed to do. This is a frustrating statement for a lot of people.
So do calculators.
Yeah. So all systems are designed, and not all systems are designed well. The software does not work right. We hear this sometimes. It doesn't work right. According to who? According to who? Works on my machine. But what we do is we do this automatic comparison. We judge software quality by how we think it should work as compared to what it actually does. But who's right? What should it be doing? Who decides in your company what the software should be doing? Is it the PO, the PM, the CEO, the CTO, the developers? Who's doing that? Well, this is the current trend. You have the business, the customer, somebody asking for a feature, talks to a stakeholder who goes to a product manager, that gets to the product owner, that gets to the analyst, it goes to the architect, that tells JIRA, then the developer comes in and reads JIRA, and then the quality assurance person gets some information from JIRA, probably gets some information from the product owner, gives some additional information to the developer, and then the release manager gets some information, and the data scientist gets nothing. Because they already know everything, because they have access to the database. Why do we need to tell them anything? Right? Well, it's interesting. The domain expert really kind of, at a raw level, knows what the software should be doing. And the developer is the one that's implementing what it should be doing. We as humans know how to really make it hard on ourselves to get something done. All right, so design brings quality. Design can bring high quality. I like this picture of this building. It seems like high quality, you got light coming in. Design brings low quality. Anybody ever drive a Yugo? All right, so all software is designed. Douglas Martin says questions about whether design is necessary or affordable are quite beside the point. The alternative to good design is bad design, not no design at all. There isn't a software program that you work on that isn't designed. There's no such thing as an undesigned software program. There's a guy named Paul Rayner. You could look him up. He did a talk at DDDEU in 2016 that mentions this and talks about how implementations of Agile, not Agile itself, but implementations of Agile have kind of messed this up and what to do about it. And then Rush, if you know the band, they have a line in their song, Free Will. If you choose not to decide, you still have made a choice. This is very important when it comes to software design. Agile principle number 9. Anybody read the back of the manifesto? It says continuous attention to technical excellence and good design enhances agility. Good design. By the way, I didn't put it in here, but if you've ever read the SAFe extended guidance, it also says you need a software model, a domain model, in the SAFE extended guidance. I don't know if anybody's working with SAFE implemented in their company, but I'm betting you didn't get the lesson on how to design a model from your SAFE implementation. Digital design focus. All right. So in UX modeling, we love it, right? We get these wireframes and we know what we're building. We love that because now we see what the user is going to experience. So if it looks good and flows well, we think, okay, yeah, we could build that. Data modeling. You know, I was a big ERD person for a very long time. If it's normalized and accurate and the customer likes the way the data, you know, is connected, it's awesome. What are we doing here in the middle, in between the UI and the data? What's our modeling paradigm? When I ask people how much percentage-wise do you have between properties and methods in the middle, in the midsection, in a complicated system? I don't know what your number is. I'm not going to put it on here. But in a complicated system, I'm guessing the methods outweigh the properties. You have a lot of behavior. And if you're not designing it intentionally, then you're unintentionally designing it. You're not undesigning it. You're unintentionally designing it by hacking away. All right. So what's success? That it just works? We're going to talk about that for a minute. Everybody remember this phrase? We don't talk about this much anymore, right? Garbage in, garbage out. We're all too a little, I don't know about you, but I'm pretty proud of my work. I never think of it as garbage going in. I'm beginning to start to think that a little more in my as I become seasoned, I start to realize. Scott Lashin says something very awesome. He says, if the input is bad, unclear requirements or bad design, then no amount of coding can create a good output. All right. So how do we make good logical designs? Good design requires several ingredients. Knowledge enables design. Missing knowledge restricts design. Creativity enables design. What do you think the lack of creativity does? Now, analysis enables good design. Freedom enables good design. So you need these four things and probably a few other things that you might think of. And domain-driven design can help you do this in that midsection. All right, so we saw this slide. How can we fix this? What if we did this? What if we put the domain experts in the center and put everybody else around them and started having a story session where we learn about how the software should work? We all get on the same page. And what if we got a subset of those and then had some modeling classes on, or modeling sessions on, and working sessions on how this software should actually work from cradle to grave in all of the weird, unhappy paths and the things that happen with the software and the behaviors and the way they should work? What if we calibrated that against the domain expert who kind of knows how that business is supposed to operate? Domain modeling. That's what we probably ought to start doing if we're not doing it now. This will help with side effects. This reduces side effects, and I'll talk about that in just a second, and I'll wrap up. The power of modular logic in domain-driven design is that you're putting walls around behavior and walls around the language of the business. And you're saying, I am only going to let this behavior operate in a certain way. You can't get at it any other way. It's protected logic. It's not in the controller. It's not in the back end for front end. Your business logic is housed inside and is well organized. Most code bases are hoarder houses of logic. That's how I've seen it. And when I get called in, I'm usually helping to untangle that and create organization in the software using domain-driven design. So I don't have time tonight in this short speech to teach everything about DDD, but there are two aspects. There's the strategic side that gives you the ability to understand your subdomains, generic, supporting, and core. And the core is the differentiator, and that's where you're going to spend a lot of time designing. The rest of it, buy the software, build it cheaply, whatever. But the core, thing that makes the business make money, that's what you want to design well. And there's a reason for it. In the tactical DDD side, that's where you're going to be doing a lot of your core work. You're building aggregated boundaries of behavior. All right. DDD allows you to upgrade the quality definition. So we talked about quality at the very, very, very beginning. Meets the need with a high degree of excellence by adding, and is adaptive to future needs. Phil talked about that in the very beginning. Change is coming faster and faster. And if we don't build software to be adaptive to the change, then we're going to just get into this undertow of continual rewrites. If you don't want to continually rewrite software, then you need software that's adaptive to change. DDD is actually very good at this if you're good at designing. So DDD will provide harmonized models when the domain changes, the language of the domain, the behaviors of the domain, that model, that's the model that's in the code. The domain expert knows what's in the code because the domain expert gave you all the terms of the behaviors. The behaviors are written in the code, the properties are written in the code. Everything is there from the domain expert's perspective as agreed upon by the technologists, and so we're all on the same page. There's no guessing. New story comes in, using that terminology, we know where it is in the code. If your teams need help intentionally designing quality adaptive systems, please consider domain-driven design and all the resources that have been provided to the software industry over the last 20 years. Here's a bunch of books, and there's a conference that's happening. It's specifically all about DDD. And that's my story, and I'm sticking to it.
Next speaker is